and we'll jump right in. So we spent Monday's class talking about NoSQL databases and how NoSQL databases usually prefer a slightly different approach to things than relational databases that we've been talking about. So what we're going to do today is we're going to take a look at probably the most popular, well, one of the most popular for sure, if not the most popular NoSQL database that's out there today, which is Mongo. How many of you have had experience with Mongo in the past at all? All right, so a very small number, a few. If you've had experience with Mongo in the past, probably not going to cover a whole lot today that you haven't already seen before, right? But the vast majority of you, it seems like this will be your first taste of Mongo. So we're going to start from scratch. We're going to start from the very beginning and talk about how Mongo behaves a little bit differently than the relational databases that we've been talking about up until this point. So first off, we need to talk about what a document is. MongoDB is an example of a document store. It's in the business of storing documents. Later on, we're going to contrast this with a relational database, which is in the business of storing tuples, right? So we're going to talk about that a little bit. Before we go too much further, definitely want to plug this book. It's a fantastic book. A lot of the examples, a lot of the stuff that I'm going to talk about today can be referenced in this textbook. So if you need a good Mongo resource to use as you work on the next homework assignment, or you just want to learn more about Mongo in general, this is a very highly recommended text. Go out there and pick it up on Amazon or something. All right, so what is a document? A document is made up of key value pairs. Every key value pair is going to have a type associated with it. The order of the documents matters kind of, right? It matters kind of. If I'm checking for a key within a document, the order that it appears does not really matter. If I'm checking to see if two documents are equivalent to each other, the order kind of matters for checking that equivalency, but it's a little bit nebulous because we don't really have a whole lot of control over that order. Much like a hash map or a map, right? We don't necessarily have control over the order that our key value pairs appear. So while that order might be used to do some sort of equality checks or other data type checks, there's not a whole lot we can do about it. There's not a whole lot we can do about that order necessarily. Unlike SQL, they are type sensitive and case sensitive, actually, is the bigger one there. So SQL didn't care if you put everything in all caps or all lowercase. It really didn't care at all. Mongo, it matters, which is actually what we're used to. And then much like a normal hash map, no duplicate key is allowed. If I try to insert a duplicate key, a key that already exists, just like a hash map, it's going to just overwrite whatever was there before. It'll erase it. Okay, and so we saw examples of documents actually on Monday. Here's a very simple example of a document. I do want to, of course, point out that this looks very different from the table format that we've been used to with rows and columns. I've got key value pairs now, right? And not only do I have very simple key value pairs like first name and last name, but I can have more complex data structures as my key value pairs. For the case of phone numbers, I have a list. I have a list of values. That's not something that is easily accomplished in a relational databases, and one of the great flexibilities of document stores, document-oriented databases. All right. And so we're going to take these documents and we're going to store them in something called a collection. So a collection is just a grouping of documents. I can take all documents that are related to each other and stick them in the same collection. Is there a schema here? Are we worried about schemas? Does my collection have an expected format that it wants? Is it going to expect all of the documents to have the same key value pairs occur? Nope. The collection doesn't care. Collection doesn't care. I can give it any document that I want as long as it's a valid document, right? Doesn't break any of the rules about what makes a valid document. Does not matter what keys it contains. Does not matter if it's got different structure. Makes no difference. The collection does not care. We talked about that a bit on Monday, right? I can also have sub-collections, which are collections of collections. You can think of a collection, honestly, as a folder, right? It's very similar in concept to a folder. I'm going to take my documents, I'm going to stick them in a folder. Sometimes I'm going to take some of my document folders and I'm going to put them in another folder. That's a sub-collection, right? That's how sub-collections behave. So it's a pretty straightforward, simple structure. All right. One of the big things that we spent a lot of time talking about in class with relational databases was indexing. We haven't actually talked about that at all with NoSQL databases, but they can index as well. They can index stuff too. An index is automatically created for us on this ID key, which we haven't talked about yet. It's kind of a little bit of a surprise, right? I've been sort of ignoring this idea of a primary key for a while, but actually there is something that sort of resembles a primary key called an ID. We're going to chat about that in just a few minutes. So indexes are automatically created on this ID, but I can create my own. And what's interesting about the indexes that we can create are that I can create them on things like embedded documents. If I have a document inside of a document, which Mongo will do, I can create an index on those embedded documents, which is going to speed up the retrieval time of that data. Or if I have, if I want to make an index on multiple keys, one index that covers multiple keys, I can do that as well. That's called a composite index. Actually, relational databases can do this too. We haven't seen many examples of that, but if I wanted to create a B+ tree that indexed by multiple columns, that could be done. My key would just be a tuple, right? Instead of a single value. That can be done. And Mongo can do it as well. In fact, the structure that Mongo is going to use for its indexes, it's our good friend the B+ tree. It's not going anywhere. It's such a powerful structure for searching that Mongo is going to go ahead and use a similar concept. All right, let's talk about design. We've talked about design a little bit on Monday. Today I want to see some actual examples of documents, and we're going to play around with actual documents here in just a moment. This database is so flexible. It will allow us to make our structure look as complicated or as not complicated as we want. And so it really comes down to us then having to choose a design that is going to be effective for our needs. With the database, we're kind of pigeonholed a bit. If you go through the database design concepts that we did in like the third week of class, you're going to end up with databases that follow a similar sort of structure: primary key, foreign key relationships, third normalization, right? Third form normalization, et cetera, et cetera. Those things don't exist in Mongo. So it's up to us to decide now. In fact, on Monday, we talked about one of the big trade-offs with designing with these documents. Does anybody remember the trade-off we talked about with data access on Monday? There were two approaches we could take. Anybody remember? Can I use foreign keys with Mongo if I want to? Can I do something that's kind of like a foreign key with Mongo? Is that possible? It is, right? I can make a number, and then I can refer to that number from a different document. That's called a reference. That's what we call it in Mongo. It feels a lot like a foreign key. So I can reference something. I can have a number that points back to a different document. The quote-unquote opposite of that, the complement to that, would be embedding. I can actually take that document and just embed it directly. Instead of referencing it, instead of pointing to it, I'll just take that whole thing and I'll just plop it right in. Mongo gives us the flexibility to do that. NoSQL gives us the flexibility to do that. But there's pros and cons, right? if I have something that uses a reference, actually, this is not a reference, this is embedding, right? I have these track documents that are embedded directly into this document for a CD. The alternative to this could be taking these tracks and making a separate collection for them, right? And referring them back to the album that they are a part of. That's the two trade-offs that I'm talking about. So if I use something like this, where the tracks are embedded directly in the album that they're associated with, what's the advantage of doing it that way? What benefit do I gain from taking this data and embedding it directly? Yeah. I don't have to do this idea of a join, right? I don't have to look up that reference, which is going to take time. The data's right there. It's right there. I can just, if I find the album that I want, I don't have to do any more work to find the tracks. They're embedded as part of the album document. If I split them up and I use references, I'll have to somehow link the two together, which is going to involve a search. And that's going to take time. What's the disadvantage of doing it this way then? Nothing's free, right? What's the disadvantage of doing it this way? What's the price that I pay? Or you could think of it as, maybe if that question's not springing an answer to mind, think of it as, what's the advantage of using a reference? What's the advantage of doing things that way? Yes. So duplicate data could be a thing. I don't know what music you guys like to listen to, right? But there are some artists who will release the same song on multiple albums, right? That happens all the time. In which case I would see duplicate information for those because it's embedded directly in the document, right? Whereas if I kept them separate and I used a reference, I could have one copy of that track and just link it to all of the albums that it was a part of, correct? So duplicate data, that's one disadvantage. There's another one. There's another thing worth thinking about as well. What if I don't care about the album? I just want to access the tracks, the songs. If they're embedded within the albums, I have to go through the albums to get there, right? That's an additional layer that I have to sort through to find what I'm looking for. Whereas if I use a reference, that means I've got a pile of albums over here and a pile of tracks over here, and I can go through them separately if I want to, right? I can just go through these tracks if I want to, or I can just go through these albums if I want to. Does that make sense? So it provides me more direct access to the data. More direct access. But Mongo gives us the flexibility to pick and choose what we want to do, depending on our application. How often do I expect to access this track data? Is it an important part of what I'm trying to do? If it's not something that I expect to use very often, or if it's not something that I expect to use by itself, like if I don't expect to ever use the tracks by themselves without also using the album that they're associated with, then embedding it is fine. That's totally fine. It's going to make things a lot easier, a lot smoother for me. If that's not true, and I plan on doing, accessing the tracks individually without necessarily going through the albums, then I might consider using references instead. Yeah, what's up?
So in the SQL databases we've been looking at, they would keep metadata about queries we've done, and then perhaps build indices or do optimizations based off of past actions.
Sure.
Could we perform similar actions here where we collect metadata about the queries that are coming in?
Yeah. So metadata is a very important part of a relational database, and actually metadata is going to be collected about your Mongo database as well. But like we've seen with other things related to Mongo, there's a lot more flexibility there. It's probably not going to be as robust or as expansive as you might expect a relational database to be tracking. But Mongo certainly will do some optimizations for us, and they're optimizations that are very similar to the optimizations that we talked about with relational databases. They just take a slightly different format because our data is in documents now instead of rows and columns. But yes, that can be a thing. Mongo will not reorganize our data for us though, right? Like that's on us. That's a choice that we have to make. That's something that we need to pay attention to and fix if that's what needs to happen. The nice thing about it is because Mongo is so flexible, if we create our design one way and we decide we don't like it or we think we picked the wrong path, it's actually relatively straightforward for us to do it a different way. Or it's very flexible as to maybe I could just do it both ways, right? Is there anything to say that I can't embed these things and have a reference for them as well? Like, can I use both techniques at once? The answer is yes. I get all the advantages of both, but then I also get the disadvantages of both. So that's not necessarily free either, but it's certainly something we could do in a relational database. That'd be pretty unthinkable. That would be not something that I would expect to see at all. So if we want to, we can kind of equate our Mongo database, our document store database, to a relational database. So with a relational database, we had the database itself, which contained tables, and those tables had rows, right? Well, the hierarchy here is we have a database with collections, and those collections contain documents. And that's roughly analogous to each other. That is it's not exactly the same, right? But it's roughly equivalent. Collection is Mongo's, the closest thing that Mongo has to a table, quote unquote. It's not a table, but it's the closest thing that Mongo has to a table, and the documents themselves are the closest thing that we have to tuples. Again, they're not tuples. We're talking about key value pairs now with a more complex structure than a tuple. But it's on the same level of the hierarchy as a tuple is within a relational database. So let's take a look at some more specifics, some more practical stuff. This is, I believe, a complete list of data types that Mongo provides. It's darn close anyway. There are not a lot. And actually, most SQL databases don't have a ton of data types either, but Mongo's list of data types is even smaller still. And most of these are generally what you would expect. Boolean values, floating point values, integer values, date values. The reason why it says careful here next to integer is because Mongo will actually try to default to floating point values, surprisingly enough. It will try to default things to floating point values. If I want an integer, I usually have to explicitly ask for it, which is a little bit different than what we're used to. Usually we're used to things defaulting to integer unless I specifically ask for a float. And actually, something else to be careful of here too is that whether or not that behavior exists as I described actually somewhat depends on the version of Mongo that you're using. So you have to kind of watch out for that as well. But anyway, some interesting things. So the first, half a dozen of these aren't particularly surprising. But then down here towards the bottom, we get to some really interesting ones. Regular expression as a data type? How many of you are familiar with regular expressions? Oh, I'm sorry. No, they're actually very powerful tools, right? Very powerful, if not a little bit confusing tools, right? So being able to store them in a database sounds like kind of an odd thing to do. Aren't they just strings? Well, yes, kind of. But by assigning them their own data type, what Mongo is really doing for us is allowing us to apply them more directly than having to parse them as a string every time. So it should give us some added performance. I can store snippets of JavaScript code directly in my database. Again, for kind of the same idea. If I want to store a little subroutine, I can actually create it and store it in the database directly. Again, you could say, well, that's just a string, and you're not necessarily wrong, but that is a piece of data that I can retrieve and execute, right? Whereas a string is not something that's easily executed on its own without some parsing and other stuff done to it first. The two that we're most concerned with, though, I'm not going to So let me be upfront about this. I'm not going to ask you to necessarily do anything with regular expressions or JavaScript code. You can, but I'm not necessarily going to ask you to. I will ask you to be aware of arrays and embedded documents. In fact, I think these two things are two of the most important data types that Mongo provides. That's really what allows us a lot of the flexibility that we have been talking about in terms of what Mongo can do and the designs that we can use with the Mongo database, right? So we've actually already seen examples of both. Here's an example of a list. Square brackets means list. Actually, it's a list of documents. So I've got a list, and then within that list, I see more curly braces, which means more documents. This one is, whoops, sorry. This slide is just a list of strings, so no list of documents here, just an array of strings. And if I want to, I can have just an embedded document as well. I may not have an example of that right now, but we'll see an example of a document within a document at some point in time, I'm sure. So those two data types are really what makes Mongo stand out a lot from SQL, from relational databases. Oh, here we go. We actually just had this conversation, embedding versus referencing. So we don't need to have that conversation again. Let's talk about the IDs. The IDs are the closest thing that Mongo has to this concept of a primary key, but there are some very important differences between an object ID and a primary key. The similarities are that they uniquely identify each object within a collection, much like a primary key uniquely identifies each tuple within a table. That's part of the role of an object ID. That's about where the similarities end, though. Object IDs are chosen for us, always. We don't get to pick them. They are what they are. In fact, they follow a very strict formula. They're 12 bytes long, and you can see the breakdown of bytes here. The timestamp is the first 4. The next 3 bytes are based on the machine that this is executed on. This is based on the process that created the documents. And then these last 3 are just a counter. They're just a straight counter that counts up. So I think it's interesting to try and understand why these pieces are necessary, right? Timestamp feels, somewhat relevant. When did I create this document? When did this document get inserted into the collection? That feels somewhat relevant. Why is the machine on here? Why do I include bytes to represent the machine, the actual physical computer that did the work? What does that tell us about Mongo? Yeah.
We expect a distributed environment.
We're expecting distribution here, right? It is prepared to handle distributed databases. And it's entirely possible to consider that 2 documents get inserted at the same time in 2 different places, right? So if I want to distinguish between those 2 things, knowing what machine they were on can be part of that process, part of what helps me distinguish. The process ID is also included for similar reasons. Did you have a question? Or yeah.
When you say each object in the collection, do you mean only documents or also sub-collections of this object?
Every document is going to have an object ID associated with it, whether it's in a collection or a sub-collection. Yeah, every document will have an object ID created for you automatically. So object here should, I guess I should edit this to just say document. The process ID exists for similar reasons that the machine ID is included, right? Within a single machine, I could have multiple processes running at the same time that could potentially insert a document at the same time. So using the process can help distinguish that. But then why is this counter here? That's maybe the most confusing one. Why do I have a value that's just counting up? That seems a little odd, right? It's a tricky thing to think about. Consider that we've got multiple levels of concurrency here. I've got different machines doing things at the same time. That's one level of concurrency. Within one machine, I've got different processes doing things at the same time. That's another level of concurrency, right? But within a single process, I have multiple threads doing things at the same time. That is yet another level of concurrency. And so this last value here, this increment, is because of that fact that threads can be spawned with the same process ID, right? And I still need some way to distinguish between the data that is manipulated by those threads. So we're really seeing the various degrees of parallelism as we go down this object ID, right? That's really why this object ID is structured the way that it is. It's showing us the different degrees of concurrency that we can expect within our Mongo database. So we don't get to pick these. They're generated. Yeah, what's up?
Will they even allow entries at the same timestamp that have that concurrent where it's literally at the same second?
So the timestamp is 4 bytes. It's probably just Unix time would be my guess, which is down to the millisecond? I think it's milliseconds, isn't it? It's been a while since I thought about it. And a millisecond for a computer is a fairly long period of time. Certainly conceivable that two things could happen within the same millisecond. Even on the same machine, it's conceivable that that could happen. Although the fact that this timestamp here has some added benefits as well. If I ever want to find out, sort data from oldest to newest, something like that, it's a very convenient way for me to do it. It's just baked right in. I don't know if that answered your question.
Yes, I don't know if it would allow the process to happen. I guess at the same time, the same database.
Allow it to happen? I mean, Mongo doesn't care, right? If anybody is going to care, it might be the operating system, perhaps. And I think that's an interesting question that is somewhat outside the scope of this class to some degree. I don't think the operating system would have any problem with that happening, though. If I've got multiple cores chugging through multiple threads at the same time, I'm just trying to get as much work done as possible, right? That's my goal. So things happening at the same time could happen, especially if the documents that I'm inserting are in different parts of the database, so they're not going to conflict with each other. Under most use cases, though, the timestamp is probably not going to be the same. We're thinking about scale here. MongoDB, to some degree, doesn't care about your tiny little databases. It's prepared for massive databases, things that are going to be accepting many requests simultaneously. All right. So with all of that said and done, my next step is to actually fire up Mongo and go through some examples for y'all. Question?
Yeah, I know the timestamps there, so it's probably unlikely, but would you ever reuse object IDs if you were to delete a document?
Would you ever reuse object IDs? It would be very difficult. I mean, again, because you really can't set this yourself. It's set for you automatically by the system. So even if you wanted to reuse an object ID, it would be difficult to do so. Mongo would not let you change the object. Actually, Mongo might let you change the object ID after the fact. I cannot think of a good reason to do so.
So like say you're inserting 3 bytes worth, or like inserting so many things that it overflows the increment.
Oh, okay. So this is 3 bytes, which would be what, like 2 to the ridiculous power. Yeah, lots of stuff. I suppose at some point when quantum computing takes hold, this increment's not going to be valid anymore for Mongo, right? We're not there yet, though. You should go pitch that to Mongo, get them to hire you to solve that problem. That's what I think. You're right. It could be an issue. That is a potential flaw with modern computing. I don't think it's going to be a particular problem. But as computing gets more powerful and more parallel, it could be a problem. I don't know if you can change object IDs after that. Now I'm curious. Now I need to look it up. Can you change Mongo ID? You cannot update it, but you can save a new ID and remove the old ID. Interesting. Why? I don't know. I can't think of a use case. It seems apparently that you can do it. I can't think of a use case unless you're like some kind of hacker or something, right? You're trying to revise history. Make it look like, cover your tracks, make it look like you weren't there or something. I don't know. It's interesting. I certainly have never felt the need to mess with it. All right. So what we're gonna do next is take a tour of Mongo. I've actually got Mongo installed on my computer. If you do not have Mongo installed on your computer, there is a web interface, I believe, on Mongo's own website. That's not the right page, I don't think. The Mongo website used to have a web interface. Did they take it out? I'm not going to spend a bunch of time looking for it. You guys are capable Googlers if you want to try and find it and follow along. If not, sit back, relax, and enjoy the show. That's totally fine too. As we take this tour through MongoDB, I have downloaded and installed it on my computer. Yeah, what's up? Did you find it?
Use so many bytes for just a machine ID. Why not put more into the timestamp?
Why not put more into a timestamp? Well, Unix time is just 4 bytes.
Or just, like, they use 3 bytes for the
They use
ID. Like,
3 bytes for the machine ID, that's right.
yeah, like how many nodes do you use? Like,
That's a good question, actually. How many nodes do we expect on a system? So 3 bytes is implying
I
a
would say 1,000.
shitload of nodes, right?
A lot, yeah.
Yeah. That's a technical term.
16 nodes would not be super long.
Yeah, no, that's a... Whoa, what the heck? Sorry, this thing's on. Oh, all right. I didn't know that. You're right, that does seem a bit overkill. I agree with you. I think, what would that be? That would be 2 to the 24th power? Oh, man. That's a lot of machines. That's 16 million machines? 16 million machines? Yeah.
I mean, depending on how we're IDing machines, couldn't machine IDs be transient? In other words, the same machine 2 years later, even if it's still in the process, may not have the same ID.
That's true.
Could change.
That's true. I mean, how do they compute that machine ID? It's probably based somewhat on the host name / I doubt it's based on the MAC address of the machine, but maybe could be. I don't know, actually. The documentation probably has information in that somewhere. Clearly, we need more than 1 byte. I think having more than 256 machines is not crazy talk. 2 bytes would be 65,000. So that's, sounds like a lot, but if you're thinking about, I'm sure Mongo would love to have the Facebooks and Googles of the world as clients, right? And 65,000 machines to them, when you think about racks and racks and racks and racks of computers doing their stuff, is maybe not outside the realm of possibility. Plus, they don't know what's going to happen in 10 years, 20 years, 30 years. They need room to grow. They need to make sure their system is still going to be viable. So, I think to some degree there's a sense of planning ahead here. Although I'm not on Mongo's development board, so I can't say for certain what their future plans are necessarily. It's a good question, though. I think it's a very interesting question. Any other questions? It's a good time to pause, actually, before we get into some other stuff. Yeah.
So is Mongo a protocol? I mean, it's obviously a company, right? But are there people who have also implemented the same protocol as Mongo, or is it really just like different companies taking different takes on NoSQL database?
It's proprietary, so I don't think that they're, the MongoDB implementation is trademarked and protected by millions of lawyers, patented, whatever, right? There are other document stores out there, though. Mongo definitely has a stranglehold on the document store market right now. That is a fact. But the idea, so I guess I sort of went off on a tangent there for a second. MongoDB is a proprietary product that you can download for free, but where do you really pay money? You pay money for support. You pay money for if you're a company and you want to deploy this across multiple machines. They'll come down, help you set it up, get everything up and running. That's how they make money. Yeah.
I think these databases companies are moving to cloud service, so now they just charge for all that for gigabytes.
Yeah.
Or,
So you're talking like AWS kind of stuff, right? Yeah. And you can spin up MongoDB on AWS servers. So I'm sure Amazon is one of Mongo's biggest customers. I have no doubt about it. None whatsoever. And I agree with you. Database as a service is definitely becoming a thing, for sure. Although there are reasons, I think, where that we're getting a little off topic, but it's an interesting topic. You're also giving all your data to Amazon when you do that, right? Jeff Bezos is dancing all the way to the bank, but everybody else is now sitting there wondering, what the heck is he doing with all my information? So I could definitely see some pushback on those services at some point in time. But again, I'm just a comp sci professor. I'm not, I have a few very small instances on Amazon, but nothing major to write home about. But it's something to keep in mind for sure. Yeah. Great questions. Any other questions? I love talking about this kind of stuff. I love having these conversations with you guys. Any other questions? All right, let's take a look at what Mongo can do and kind of how it's set up. I have Mongo installed on my computer. You can download it for free, actually. It's a free application. You can go download it. There's two pieces. There's the client and there's a server. So I've already got Mongo installed, and MongoD is the Mongo daemon, I don't know, that you run that acts as the server. And then mongo.exe is the client that connects to the server and allows us to do database operations. So first thing I need to do is start the, oh, that's annoying. Start the server. Where's my cursor? Am I off the edge of the screen for real? Oh no. Is that too small? Can you guys read that?
That's good.
You sure? We're good? In the back? We're good? All right, cool. All right, I'm gonna start up the server, and it spits out a whole bunch of server stuff. That's great. I don't really care. I want to run mongo.exe, and it starts a whole bunch of, where am I, though? Hi. Oh, am I off the bottom of the screen? Okay, there I am. That's good. Sorry. One of the most frustrating things about teaching is I have to blow my text up, and then I go home and I write code in my fonts like size 32, and it's just, sorry. All right. So here we are. We're logged into a shell, a Mongo shell, and now we can start issuing Mongo commands. And so some of the simplest commands that you might see are something like show databases. So here are the databases that currently exist. I did not create any of those. Those are just Mongo's default databases that are used. You can see there's not much in them right now because this is a fresh install. I really haven't done much on this server yet. So admin, config, local test. All right, so I want to make a new database. I want to do something. To make a new database, all I say is I want to use it. So I'm going to make a database called library. Just say use library, and it's switched to database library. There's no data in it yet, but we're going to take care of that in just a second. Now remember, what comes under databases in the hierarchy? Database is top level, and then collections, all right? So if I want to see what collections are available, I can say show collections, and I haven't put anything in there. There's no collections. No collections. So let's fix that. Let's put some data in. I've got a handy cheat sheet here of stuff that I wanted to do. So we're gonna put in a document. We're gonna insert a document. I'm sorry. I should not wing it. I should stick to the script. We'll wing it a little bit later. So I'm gonna make a document. Here is a document. It's typed out. That's really annoying to have to type that out for sure. But think about this in practice, right? I'm not gonna sit there and type out documents. I'm going to get this data from an application layer, right? And it's going to form the document and submit it for me on my behalf. So we can see that I'm inserting a book. Oh, hey, this is the same book that I was talking to you about earlier, right? It's got the authors. I'm going to make that. I'm actually storing it in a variable, and then I can say db.library.insert one document. I think that syntax is right. There we go. And it tells me some interesting information. It says, all right, I acknowledge you wanted to insert this document, and then it tells me the ID. There's the ID that was generated for me, 12 bytes. It's in hexadecimal. So if I really wanted to, I could reverse engineer this, right? See, all right, so how many timestamp must be this? 4 bytes? 1, 2, 3, 4. That much, yeah. So there's the timestamp portion. The next 3 bytes are the machine. The next 2 bytes are the process, and then the increments, right? So it generated that for me automatically and inserted it. And if I take a look at my collections now, because I've actually inserted something, I have a collection called library. It exists. I don't have to create it. I don't have to say make a collection. I just start putting stuff in. It's like, oh, okay, you want me to make this collection? I get it. It just does it for me automatically. Okay. So let me insert some other stuff because I want to populate this so that we can do some more interesting examples. I'm going to put in a book and a CD. You can see, so check it out. The last few bytes of the object were increments, right? Was it 3 bytes? 1, 2, 3. So there's the increment, 4A34DE, which is 1 higher than the increment for the previous one, right? It went up by 1, just like I promised you. Just like Mongo promised us. We can see that in action. The remaining stuff stayed the same except for the timestamp because I sat here running my mouth for however many milliseconds this is. All right, cool. We've inserted some data, so now we're gonna query some data. We're gonna get some data back out. The simplest query that you can run is, oh, did I insert this into media? Oh, media is the, hold on a second. Did I do something wrong here? Hang on. I made 2 different collections. I didn't mean to do that. I'm a dummy. This one says media. That's the name of the collection. The other one I did was library. Whoops. Let me redo this real quick. And now I can show you how to delete a collection. Drop library. I don't need that one anymore. I don't know why I did that. Oh, shoot. db.library. I got my syntax off. Drop. There we go. All right, cool, yeah. I don't know why I did that. My brain was thinking library and my examples said media. My bad. All right, so if I want to grab everything that's in a collection, db.collectionname.findAll is it lowercase? Oh, it's just find, my bad. Yes, excuse me, there is. Tab autocomplete, like most modern terminals. And there are the 2 documents that I have, and you can already notice, which I hope is not a surprise, right, that these documents don't have the same format. They share some things in common, they share some things not in common. And Mongo doesn't care. Mongo's not going to stop me from doing that. Right? Okay, so this is the equivalent to select star from media, right? That's the quote-unquote relational equivalent. Let's take a look at some more querying that we can do. Here is a query that we can run. Now you can probably tell from the way this query is written, I'm looking for all documents that have the artist given as Nirvana. So that gives me back this CD. CDs in 2019. Well, what is this equivalent of? What relational operation am I doing here? Select, which is equivalent to what in a SQL query? A where clause, right? A where clause. So how do I do a where clause? I pass a document. I pass a document with my criteria. Where artist equals Nirvana. That's what I'm saying here, right? So this is equivalent to a selection. And you know, if we take a look at this next one, probably not a major surprise here. Get rid of this query. That did I not copy it? Thought I copied it. So I have artist Nirvana, but then I have title : 1, And the only thing that I got back from that document, except for the ID, it also included the ID, interestingly enough, is the title. What is this an equivalent of? What is that piece? Projection. That's right. It's a projection. So I've got, if I'm going to write a MongoDB query, I'm going to pass in documents. The first document is my selection criteria. The second document is my projection criteria. Yes? What's the one do? It's like a Boolean. One means I want to include this. If I switch that to a 0, that means don't include this, and it'll include everything that's not the title, right? So it's an on-off switch. Good question. So it's sort of a inverse projection when you put zeros in there in some ways, but a projection nonetheless. So our good old relational algebra operations are still kind of here, right? Kind of. They look a lot different. This is not a SQL query by any stretch, but shares some similar concepts. Sorting. So I can sort things as well. There's a sort function that I can apply, and I have to pass a document that indicates what I want to sort by. So sort it by title. The title is this book. D comes before N, right? In the titles. So it's managed to sort. And I can sort by multiple columns if I want to I said columns. I can sort by multiple keys if I want to by just sticking an additional key inside of that document. Everything's documents all the way down. Hopefully by now I've run enough examples to where this next question is fairly obvious. What kind of code am I writing right here? What kind of code is all this stuff? Anybody? It's JavaScript. This is a JavaScript shell that interacts with a Mongo database. So if you've written JavaScript, this should feel kind of like home to you, right? If you haven't written JavaScript, well, you're lucky. JavaScript is a very nasty language. We're not going to write a lot of JavaScript outside the context of, oh yeah, thumbs down. Okay, we'll talk about it after class. We're not going to write any JavaScript outside the context of interacting with MongoDB, right? In all fairness, I actually don't hate JavaScript. I don't hate any programming languages. Some of them have various things they do better than others. And JavaScript just doesn't do anything particularly well. Yeah.
So all the documents can be like structured differently, right?
They can.
Okay, so if you try sorting by something that exists in one document but not another.
Ah, great question. Let's give it a try. So what's an example of that? Would be artist, I think. It only gives me, oh, that's the wrong query, my bad. I didn't do the sort query. Whoops. Did it go away already? There it is. Artist. So it did give me both objects back, and actually it gave me the one without an artist first. So it must be assuming then that artist is empty string, perhaps? Yeah, that would be my guess. I'm not 100% positive, but that would be a reasonable guess, I think. Yeah.
Why do we use artist:1?
That's
just so that we have an object in the past.
That's the column that we want to. So this is a document. Documents are key value pairs. I can't just say artist because that's not a key value pair. That's just a key. I have to say key value pairs, right? Or if we want to think about this from another angle, I can sort by multiple columns at once, and if I really wanted to, I could say sort by these columns, but don't sort by this, or I keep saying columns when I mean keys. I could say sort by these keys, but don't sort by these keys by putting zeros next to them. In practice, we would never do that. We would just omit those, right? There's no need to type out the zeros. We just leave them off. But in theory, we could type it that way. We could be explicit about it. So yeah, kind of two different ways to think about that. I have to have a value associated with it. Yeah, what's up?
So like if you were to put sort by artist 0, then which like structure would it try to sort?
Bad value, bad sort specification. It was onto your clever ruse. Yeah. It's not going to take that.
So then, like,
I have to give it something with a 1, right?
you have to give it a document, and that's the only reason that we're at it. Like, we're tacking on the full one there.
To some degree, yes. I have to give it something with a 1, but if I wanted to also include something with a 0, I could, like title 0. Like, this syntactically is not wrong, but what does it mean? It says sort by the artist, don't sort by the title. Well, if I left this off, it wouldn't have sorted by the title anyway, so I just wasted my time by typing it out. Yeah, sure, let's see. Oh, no, actually, I didn't take that either. Even better, it's forcing me not to waste my time. Don't bother. It's not going to accept zeros there, yeah.
Can you use any JavaScript truthy value? So could you do like artist 2?
Let's see. Nope.
No. Okay.
Not going to work. Anybody else got something they want to try and stump? Try what? -1. Yeah, that works. But it's reversed. It's reversed. Clever. It's reversed. Does it have to be a number? 1. Nah. Has to be a number. What's up?
So for the find, when you just say title 1, you're saying that you just want a title?
I'm saying I only want the title, yes. And it decided that I want the object ID as well. It always thinks that I want the object ID, which, it's not necessarily a bad thing.
Okay.
Yeah.
So if you don't specify anything, you will just return all the keys through?
If I don't include a projection, that's the same as saying select star, right? Give me all the keys. Yeah.
Can you project off the object ID?
Can I project off the object ID? I believe I can. Let me see here. Maybe that's not the best one to try. It's _ID 0. Well, let me do this. Let's see. Yeah. I can project it off. Yep. You can tell that it doesn't really want me to, right? It's being a little bit aggressive with the IDs. But I can tell it to shut up if I want. Awesome. Any other questions? All right, let's have some more fun. So all we've done so far is querying. Let's talk about aggregates. Aggregates can get kind of crazy. Actually, the simplest way, so like if I just want to get a count, which is an aggregate, that's very easy. That's not a hard thing to do at all. There's two documents in there, right? That's very simple. But what if I want to do something like a group by, right? That's where things get a little wild. So the way that things like group bys work is I specify this group function, but then I have to pass in a document which indicates what it is that I want to group by, and then I make up my aggregate value, and I provide a reduction. Called a reduction, same sense that MapReduce, right, has a reduction in it, that will apply to every item within the group. What operation do I want to happen for each document in the groups that I have specified? Here I'm saying that I want to add 1 to the total, right? So basically this is a count operation grouped by title. This is a count operation not grouped by title. This is a count operation grouped by title. That's the difference between those two. I have to use this group function, which is expecting the key, an initial value for my grouping, my aggregate variable, and then a reduction. It's a bit complicated. However, with that complication comes more flexibility, right? This is a simple counting. I could do something that's much more complex here if I wanted to. This is JavaScript code, right? I can write any valid JavaScript code here that I want within reason, and it will run that code during the reduction. So I'm not limited to simple aggregates like averaging, summing, things like that, counting. I can do whatever I want inside of that reduction. But I can show you that this will, in fact, do. So here's my big old query. The result that I get is a list a list of documents where each document represents the group. I said group by title, so I've got one group for this title and one group for this title, right? And the total number of things in this collection with this title is 1. If I'd had another thing in here with the title of Nevermind, this would have been 2. It's just counting the number of things that have this particular title. Yes?
2 questions. One is, for the key, can we use title 1?
For the key, can we
Yeah,
use
what?
title 1? Let's try it. Let's see. Will it remember my... Yep.
And then second question is, can we group without the initial and reduce and just call the count on the resultant group?
Can we group without the resulting reduce? I don't think so, but I'm certainly happy to give it a go. So group, so you're saying
With just key and get rid of initial and get rid of reduce.
take out,
Like, will it give us a list of documents grouped by
so like
title?
this count, right?
Sure.
Reduce has to be set is the error message that I'm getting there. Group is expecting a reduction. That is a non-optional parameter. Yeah. That's pretty close to what I expected to happen. Yep. Is it complicated? Yeah, absolutely. But if you haven't been able to tell already, Mongo is after flexibility. That is one of their very clearly stated goals, is they want absolute control, absolute flexibility. And if that comes at the cost of making things a little bit more complicated, so what, right? You've got the power. You can now decide to use those tools however you want. Any other questions on aggregates before we take a look at some other stuff? Yeah, what's up?
Can you use multiple variables?
Can I use multiple variables? Yeah, I can initialize multiple variables here. That's true. Yep. They all get put inside of this object called previous, and then I can just access them in a very JavaScript-y kind of way. Yep. And update them accordingly. Any other questions? Let's take a look at some conditionals. So I'm gonna, real quick, I'm going to insert some, okay, sorry. I'm gonna insert some DVDs into my collection now. So I know I'm going through these very quickly. Just to recap, I didn't do anything too crazy. I inserted a DVD for The Matrix, which is my favorite movie of all time. Blade Runner, which is also a very good movie, and Toy Story 3, which is exactly like the other 2 movies. Same category. Very good movie though, right? Excellent movie. And so what I want to do now is run some conditionals now that we've got some additional things to play around with. It says updates, actually, that's the wrong place for that comment. So here we go. Here's another query. And the thing to pay attention to is this guy right here. $sign is your syntactical giveaway, right? We're doing a conditional here. We're doing some kind of a conditional here. So find all values where the release date is greater than the year 2000, right? Came after 2000. And then what is this saying? Don't include the cast. I don't care who was in the movie. I just want to see what movies were released after the year 2000. So the only one that qualifies is Toy Story 3, I believe, right? Yeah, it's the only one that qualifies. Something else to notice is that, all right, this is a document, but I'm actually using an embedded document for the conditional. Here's an example of an embedded document used for the purposes of querying, right? Used for the purposes of querying. So, that stands for greater than. All the usual suspects are there. Less than, equal to, not equal to are all present and accounted for. You can use them however you like. So here's greater than or equal to. Here's less than. I don't really feel like we need to do all of that stuff. Here's one that's useful, the in keyword. And notice that I provide a list. So now I'm saying it can match this or this or this, right? If the release date is any one of these values that is in the list, I want to see it. And then here we have an OR condition. So I'm saying retrieve all, what the heck? Oh shoot, I didn't copy it. This query is saying retrieve all documents that either have a title of Toy Story 3 or have this particular ISBN. It can match either condition, right? Match either condition to be included in the results set. And so I have two documents, one for the movie and one for the book with the ISBN. Notice that for OR, I provided a list of documents. If what I'm looking for matches any of the documents on this list, then it will be included in my results set, right? We're really just kind of scratching the surface of conditionals. They can get a little bit more complicated than this, and we might see some more of that on Monday when we talk about the next homework assignment. But one of the big takeaways that I hope that you get is $ means we're doing some kind of conditional processing on our query. All right, a couple more things to chat about, and then we'll do some exercises. Updates, if I want to change documents, I want to modify documents. So here I'm going to run an update. Gosh darn it, forgot to copy it again. We're gonna run this update, and what this is saying, so here's another $ used in a slightly different context. It's saying set the type of this to be DVD, set the title of this to be the matrix, right? And you might be thinking to yourself, well, aren't those already what's in there? And the answer might be yes, actually. But then one of the interesting things about updating is this last document here. This is an optional parameter. You see it says upsert equals true. Upsert is a hybrid word between update and insert. We're saying that if a document exists, if you find this document, right, it already exists, I want you to just change the existing one. Yeah, if you look for this document and it's not in there, then just go ahead and insert a new document with these properties. So it will either update or insert depending on whether or not that document already exists, which is a kind of a convenient thing to do, right? Yeah.
If you were to update an existing document if you were to update an existing document that has more than those keys, would it delete those keys, or would it just...
No, it'll keep them as is. Yeah, it won't touch any keys that aren't mentioned here. Yeah. Which is what a SQL update does as well, right? It only touches the columns that I tell it to, and it leaves the other ones alone. Same idea. Same idea. I don't know if that actually changes anything or not, but when I have an extra $, my bad. All the way up front. But when I run an update query, it will actually tell me, did it find a match? It did. Did it change anything? It did. It changed one record. It changed one document. And so there's a difference between update 1 and update many. Update 1 will just find the first matching document and stop. Update many will change all of them. So if I expect multiple documents to match the criteria, I can use update many. Excuse me. Here's an example of, I believe, adding a new key value field, right? The genre field does not, or actually it does exist. I take that back. Genre exists, it's just changing it back to sci-fi. Here's an example of removing a field. Unset. We'll simply delete the field. Let's take a look at that one. I swear I copied it. I swear I copied it. There we go. And then if I do media and look for the matrix, which is right here, you can see that the genre key is now gone. It's now gone. I told it to unset that key, so it just removed it. Before I take a look at this last section on deleting stuff, I want to take a quick little detour and talk about the physical storage for this database, right? Everything we've been looking at, these documents are in a format called JSON, which stands for JavaScript Object Notation, I believe, if I'm remembering that properly. I'm getting the thumbs up. Cool. The physical storage of this is actually done in something called BSON, where the B stands for binary, right? So I'm taking a JSON document and converting it into a binary representation, which I hope is not a particular surprise to you. We want to optimize the storage as much as we possibly can, which means I'm going to deal with it on the binary level, the ones and zeros. That's going to provide me the most flexibility in terms of optimizing our data storage, right? The BSON implementation that Mongo uses, again, is proprietary. That's kind of the secret sauce. So there's not a whole lot of details out there about exactly how it works. They have distributed some information about it, but there are some things that we can find out about it. For example, if I open a new command prompt and I go and I go to, where is it stored? It's on my C drive. Here we go. This folder called data is where Mongo is stashing the physical representation, the files that back this database. So DB, you'll notice every command that I've used started with DB, right? The files are in there, DB. I'm off the bottom of the screen again, sorry. So if I look here, all right, now I'm starting to see, here's collection. I can see the collections that exist. I can see the indexes that have been created automatically on my behalf based on the different collections. Wired Tiger is actually the specific BSON implementation. Wired Tiger is the engine that manages the binary values. I think there might be a little bit of plain text in here, though. Let's see if I can open up one of these collection files and see if we can discover anything about it. Oh, no. That's no. Let's try a different one. Let's try number 7. Hang on, let me check the dates on these. Which one has been modified recently? November 13th. Oh, that's the index. What about the oh, they have all been modified today. Okay, interesting. Which one had, oh, this one's a little bit bigger though, right? This one's a little bit bigger. Collection 7. Oh, no. Well, oh, hey. Oh, I recognize some of that stuff, right? I think we found it. I think we found where the physical storage actually is. What's all this other chunk? I don't know. They don't want me to know necessarily. It's stuff that Mongo is doing to optimize the data storage here. So, you know, the files are there. They do exist, and you can see them if you want. The journal is, I believe, Mongo's, it's Mongo's log. So just like we had log files on a relational database, here are the log files for Mongo. All right. Let's wrap up then with a few deletion examples. So if I want to delete something, I've got, just like I had update one and update many, I've got delete one and delete many. So I can, if I want to go in and delete, db.media.delete many. And if I pass an empty document, that's like saying there's no selection criteria, right? It's just everything. Just delete it all. Acknowledge, true. How many documents did it delete? It deleted all 5. So now if I try to see what's in my collection, it's nothing. It's empty. It's nothing. The collection itself still exists, though. The media collection still exists. I didn't delete the collection. I just deleted the documents contained within. we already saw how to delete a collection when I screwed up earlier. We drop it. And now I am back at where I was before. None, there are no collections. Oh, whoops. Got parentheses happy. There are no collections. And I wonder now if I go back to the physical storage, you can, oh, that's the wrong folder. Well, it says there are still collections. So it didn't necessarily delete the data itself. It just deleted some references to the data is what it looks like to me. Or did it? I don't know. Is the data actually in here? Let's see. Yeah, it's still there. It's still there. What does that tell you? What does that tell you? Yeah. There's like a header or something, right, that's tracking, is this data live or not? Right? Much like we saw with our heap files. We didn't actually have to remove the data. We just flipped the header bit to 0, which means something else can come along and erase it later if we want to. It's faster that way. It's faster deletion that way. Is there a quote-unquote header? I don't know. Maybe. Maybe that's what this A whatever stuff is. Possibly. Yeah. That's how Mongo does it. That was it for my little Mongo demo. Does anybody have any questions? Yeah.
Do you have the permission to read it directly from it?
I'm sorry?
Do you have the permission to read it directly from it?
Oh, if I wanted to just delete the file?
Is that, do you have the permission?
I do, because it's my computer, yeah.
Oh,
Yeah.
like the physical storage. So if you delete the physical storage, you said it probably might delete the header, but not the actual content itself. But what if you delete directly from your religious global?
Well, it's already removed from the database anyway, because I told it to remove the collection and the data that already existed. So I couldn't get back to it from the database anyway. But you know, this is my machine. If I want to blow that file away, it says permission denied. Well, screw you, right? I can do it if I want to. Oh, come on! What? How dare you? This is my computer. Well, now I'm mad. Who owns this? Me. I own it. It might be because the Mongo server is currently running and it doesn't want me to delete the file while I don't know. I'm actually a little confused. The server's still running, so I have to kill the server process first. All right, the server's been terminated. Well, let me do it now. I kind of think that it won't, but oh, it did. Yeah, it was because the server was still running. Whew. All right. Whew. I feel a little better. Yep, feel a little better now. I don't know how Mongo would react to that. My guess is that if I started the server up again, like if I hadn't deleted the collection inside of Mongo and I just deleted the physical storage, my guess is that one of two things would happen. Either it would just say, oh, the data's gone, that collection must be gone, and just kind of shrug its shoulders, or it would say, I was expecting this file to be here, where the hell did it go, and give me some kind of an error message or something. Those are the two possible outcomes that I would expect. Yeah.
I have another question. So,
Yeah.
There are a lot of NoSQL databases out there, Firebase, and what do you think are the major differences between them, and why in particular are we learning Mongo?
So there's a couple, that's a fantastic question. There's a couple reasons that we're learning Mongo. One reason is because it's very popular, you know, which is maybe not the greatest reason academically to learn something, but it's a very practical reason to learn something because it's very popular. It's used a lot. It's a common database implementation. But we are going to see some other NoSQL database implementations next week, actually, as a matter of fact. So I don't want to focus just on Mongo. I'm going to show you a couple other ones as well. We're not going to look at Firebase or Dynamo, actually. But, you know, there are other document databases out there, document stores out there. There are other NoSQL databases out there that are also popular, like the ones you mentioned. Cassandra is relatively popular, which we just don't have time to talk about them all. I had to pick and choose, and since Mongo is like everywhere and growing quickly, it seemed like a natural choice. So hopefully that answered your question. If you're interested in NoSQL databases, I have experience with Firebase and other NoSQL databases as well. I would love to have a chat with you about that sometime in office hours. Yeah. All right. Thank you so much for your wonderful suggestions today. Have a wonderful weekend, everybody. And when you come back on Monday, we'll talk about homework number 5, the last one. See you then.